Alright, so in this video, we'll be examining arithmetic series. We'll be considering difference between arithmetic mean and geometric mean. We'll be considering arithmetic sequence and geometric sequence. So let's quickly dive into some of the applications. Alright, so we have an example. We have 3, 7, 11, 19, 23, 27 as an arithmetic sequence, and we have 3, 6, 12, 24, 48, 96, and 192 as geometric sequence. Now you notice that there is a pattern in all of these numbers that are represented. So if you look vividly, you notice that there is a common difference in the arithmetic sequence. We have 3, 7, 11. So all of the numbers that we have are added by 4. So we have plus 4, plus 4, plus 4. So those 4 values that are coming forth is what we refer to as arithmetic, is what we refer to as common difference. And similarly, when you check for geometric sequence, you notice that you have 3, 6, 12, 24, and there is a pattern. So you check out for the pattern. You see that whenever you multiply the first number by 2, you have the second number. You multiply the second number by 2, you have the third number, and so on. So the 2 is indicative of the fact that there is a common ratio. So we have common ratio for geometric sequence and common difference for arithmetic sequence. Now, the first term 3 is A1, the second term is A2, the third term is A3, the fourth term is A4, the fifth term is A5, down to the seventh term. Now, assuming you have larger numbers whereby you cannot find all of the terms. So if, for example, I ask you to find the 25th term, it will be taxing for you to start adding 4, 4, 4, 4, 4, 4. So that was why we come about the general formula for arithmetic sequence. So therefore, the general formula of arithmetic sequence is represented as A's of n equals to A1 plus n minus 1 multiplied by D. Now, An is the general term, A1 is the first term, n is the number of sequence that is present, and D is the common difference. So let's assume we want to find the fifth term. You can see clearly from the arithmetic sequence that the fifth term present is 19. But should in case you want to use formula method, you use A1 is 3 plus the fifth term, which is n, that's number 5, that's 5 minus 1 multiplied by 4. So when you do your calculation right, you have the fifth term to be equals 19. So that is for arithmetic sequence. So similarly, we can also use the same approach for geometric sequence. Alright, now when you look at this geometric sequence, we are asked to find the sixth term, and vividly you can see that the sixth term is 96. So should in case you are asked to use the formula method of finding the sixth term of a geometric sequence, you use the normal formula A's of n, A1 r raised to power n minus 1. The reason why we use the general formula is in situations whereby you have larger set of numbers. For example, if I ask you to find the 28th term, it's going to take a while for you to get to the 28th term. So you won't have to pass through the process of start multiplying by 2, by 2, by 2, and you then start counting. So this is the reason why the formula method is faster and is suitable. So as clearly seen, we are finding the sixth term. This simply means that the value of n is going to be 6, and the first term is 3, and we are asked to find the sixth term, which is A of 6. And by doing this, we have 3 multiplied by 2 raised to the power of 6 minus 1. 2 raised to the power 5 is 32. 32 multiplied by 3 is 96. And you can confirm this from the given sequence. So let's move on to the next phase. Now, you can also be asked to find the mean of an arithmetic sequence, or the average mean of an arithmetic sequence. Now, whenever you're asked to find the average mean of arithmetic sequence, it simply means that you should add, for example, the formula is m equals a plus b divided by 2. So a is the first term and b is any of the term that we are looking for. So let's say we are finding the arithmetic mean of the average mean of 3 and 11. So that's going to be 3 plus 11 divided by 2, and that is equals to 7. And you notice that 7 that we have is the second term. Do you understand? So when you are asked to find the average mean of a particular number, the answer that you get is going to be the solution of is going to be the mean between the two different numbers. For example, now let's say you are asked to find we want to find the average mean of 7 and 23. Now if you look at 7 is the second term, and when you count, 23 is 1, 2, 3, 4, 5. 23 is the fifth term. So we are finding the average between the the second term and the fifth term. So when we add the two of them together and divide by 15, we also have we have 15, which is also the mean. So you notice that 15 is at the middle. You get it now? So whenever you have to find the mean, the answer must always be present in the arithmetic sequence that is given. So similarly, the same way we find mean of arithmetic sequence, we can also find the mean of geometric sequence. Now, similarly, we have the geometric sequence. I want to find the geometric mean. So to find the geometric mean of 3 and 12 is you multiply the two of them and take the square root. So 3 and 12, that's 3 times 12, that's 36. The square root of 36, that's 6. And you can see that the geometric mean is also in the geometric sequence, which is 6. Similarly, let's find the geometric mean of 6 and 97. Geometric mean of 6 and 97 is going to be 6 multiplied by 97, and our answer is 24, which is also in the sequence. Now, geometric mean is not limited to just two numbers. It's not limited to just two numbers. Should in case you are asked to find the geometric mean of three numbers, let's say you are asked to find the geometric mean of 3, 6, and 12. The geometric mean of 3, 6, and 12 is going to be 3 multiplied by 6 multiplied by 12. But now, this time around, you will not take the square root. What you will take is what? The cube root. If you are asked to find geometric mean of 4 number, you are going to take the fourth root. If you are asked to find geometric mean of 5 numbers, you are going to take the fifth root, and so on. So that is how to find geometric mean. All right, so we have now, assuming you are asked to add all of the arithmetic sequence together. Assuming you are asked to add all arithmetic sequence together. Now, this is when the nth term of arithmetic sequence come in. I mean, when they ask you to add 3 plus 7 plus 11 plus 15 plus 19 plus 23 plus 27, when you are asked to add all of them together, that is when the general form or the nth term of the sum of nth term of an arithmetic formulas or sequence comes in, right? So for most textbook, the general form of the sum of arithmetic sequence is n over 2, open bracket, 2a plus n minus 1, close bracket, d. But you can as well use this formula. You can use x of n equals to a1 plus an over 2 multiplied by n. You will still arrive at the same answer, where a1 is the first term and an is the nth term. Are you getting it now? So let's assume we are asked to find the sum of the first seventh term. All right, so you notice that an is the nth term. So we are finding the sum of the first seventh term. That is, we are adding the first seventh term together. So a1 is given as 3. The seventh term is given as 27 if you count vividly, divided by 2 and multiply by 7, because we are dealing with what? The seventh term. The n values that we have, if you count the arithmetic sequence, there are 7 in numbers, so that's n. So by simplifying, we have the sum of the first 7 term to be 105, and you can do this manually and check if it is correct. You can add 3 plus 7 plus 11 plus 15 down to 27. You will still arrive at 105. So similarly, we are going to use the same approach to find the sum of the nth term of a geometric sequence, and the formula is a1 open bracket 1 minus r raised to power n divided by 1 minus r, where n is the number of term and r is the common ratio. All right, so we have for geometric sequence, we want to find the sum of the terms in the geometric sequence. Sum simply means addition. That is, we are adding all of the terms together. So if we are adding the sum of the first 6 terms, it simply means that we add 3 plus 6 plus 12 plus 24 down to 192 together. So when you add everything together, you are going to have 189. Do you get it now? So secondly, you can also use the formula method. The reason I said this earlier, the reason why we usually use the formula method is cases whereby we have longer values of numbers that will take you time for you to start adding up. That's why we use the formula method. So we use a1, 1 minus r raised to power n. R is our common ratio, a1 is the first term, and by the application of these, you see we have 3 open bracket 1 minus 2 raised to power 6 over 1 minus 2, and by simplifying that, we have this as 3 multiplied by 63 divided by 1. The negative sign cancels out, so we have 189. So using the formula method and the manual method of adding up still arrive at the same answer. So let's quickly check the difference between series and sequence. So most people confuse series for sequence. So there's a clear distinction between series and sequence. Sequence are usually separated with a comma sign, while series are usually separated with an addition sign. So 3, 7, 11 to 19, this is a sequence. 3 plus 7 plus 11 down to 19 is a series. So we usually use the summation symbol. So we'll get to do that as time goes on. So for series. Now, we have different patterns or different representation of series. We have the finite series and we have the infinite series. Finite series simply means that there is an end to the series. And finite, the same thing goes for finite sequence. Finite sequence simply means that there is an end. Meanwhile, we also have infinite. Infinite means there is no end to the sequence or there is no end to the series. So let's check some classifications. Which of these is a finite sequence? Which of these is an infinite sequence or series? So as you can see, we have sequence. Let's do the classification. We have A is a sequence, B is a sequence, C is a series, D is a series, E is sequence, F is series, G is also series. So you know the criteria for classifying whether this is a series or sequence. Now let's move on to which of them is a finite series or which of them is a infinite series or sequence. So the first one is finite sequence. We have the second one, infinite sequence, infinite series down to finite series. So you should take note and you should be able to categorize which of these series or sequence is finite or infinite.